terms of what a data scientist actually does anyone want to give me a definition? No one? All right. Yeah. In my mind, there's two kinds, right? There's one that does analysis and one that does algorithms. And it's often the case that, like, people who are in computer science, they want to be like machine learning algorithms, all this stuff. But a large part of data science is doing the analysis and solving business problems and really helping your company figure out what's going on and how to improve the organization. So with that being said, even if you want to do more algorithms work, it's really important to still be able to do data analysis, because without understanding the assumptions we're making on our models and without being able to confirm these models, it's really hard to do a good job. And so really here, what we're going to do is, ideally, once you're able to make really complex transformations in your data and simple data visualizations, I think you'll get a lot of productivity out of it. So before we get started, what we want to do is we want to go into RStudio and create an R notebook. So I'm going to give you some time just to follow along, and if you guys can't follow along, we'll post this online on the GitHub repository later. So once you create this notebook, you kind of see some demo over here. Right? You have this header here that tells you the title and the output. There is some markdown, which we won't worry about. And within these triple ticks, you have this R code. So if you can press command return, it'll return what the function does for you. And in this case, it returns a clock. Once you're done the analysis, what you can do is you can do, let me see if I can find it here. We can do a preview, or we can do knit to HTML. If you knit to HTML, what happens is it turns your entire analysis into an HTML code block. So here we basically have our analysis, we have a plot that we show underneath, and we have some description of the data. And by doing this, we're able to communicate effectively with other people, and we're able to make things really reproducible. This document is both the analysis and the code. So the idea is that if you can give this document to anybody else, they'll be able to reproduce your analysis and really have confidence in what you do. So I'll do an example with this notebook. So once we knit this, this is going to be here. These are running the code blocks. And once it's done, we'll get a document rendered. So this document is basically everything we're going to be talking about. What's the difference, et cetera, et cetera, et cetera. Here I talk about analysis and analytics. And again, I'm going to reiterate on the importance of doing data analysis, which is that if we just use models and don't really think about what the algorithm is doing, we will fall into this trap of just like messing everything up. So there's this famous example called the Zombies Quartet, which is 4 data sets. And when you fit a linear model to each one, you get the same R squared, you get the same coefficients, you get the same residuals. However, when you visualize it, we see that everything is completely different. Right? Only one of them, the top left one, actually satisfies the assumptions we need to fit a linear model. Here we have some, parabolic curve. There we have a perfect linear fit with one outlier. And over here we have a horizontal line with one outlier. And had we not done this analysis, we could have accidentally fit this model, moved it in production, and realized that everything was destined to fail. So can everyone see the code that I'm going to be talking about here? So the first thing I want to talk about before we do any coding is something called tidy data, which is kind of the best way to format data. And to do that, we need 4 different conditions. We want every variable to form a column, every observation to form a row, each observational unit forms a table, so a data set, and lastly, every observational unit, they can be stored in multiple tables using joins. So here's the example. Every variable forms a column. So in this data, what are the variables and how many are there? Does someone have an answer?
3.
Yep. 3, right? There is the country, there is the year, and whatever is under the year. And when data is formatted this way, it's actually unclear what that number is. We'll eventually learn that it's the population, but in oftentimes, it's actually really hard to do data analysis in this form, right? Like if this data was in SQL and you wanted to take the average of every column, you would have to write code that, for 80 columns, you would have 80 aggregates. And it's also not clear what the variable names are. So the first thing we can do once we run this command lets us use the Tidyverse. Once we run that command, we can use something called gather. And what I can say is I want to gather the year variable, call it the population, and I want to take the second and third column. Right. So R is one index, and so what that does is it basically takes these two columns, 1999 and 2000, and splits them into two columns, year and population. I'll explain what this operator does in a minute, but basically when we run this code, we kind of rotate the columns and get ourselves our tidy data. So now we have country, year, and population. The other thing we can do is spread. So here we have cases and population in a variable called type, and we have a count variable. But what this does is it makes division really, really hard if you want to compute something like the cases per population. So here what we can do is something called spread. So here I'm spreading the type and the count. So I'm kind of rotating the type column into the column names, and then having the counts sit underneath. So you get that. And now we can compute things like cases divided by populations really, really easily and make sure that we're aligned on the country and year variables. There's a few other transformations like unite and separate that we don't really need to talk about, and it's really rare that we see examples like this, but I can kind of do one on the board right now. Which is, is anybody interested in doing things like data for social good or like helping nonprofits? I suppose. A lot of the time when you do that kind of data analysis, the data is formatted really, really terribly, and it's often the case that it's not actually tidy. And so what happens is we'll have something like a country variable, which is like USA and Canada. Right? And then you'll have super strange variables where it's like M_1_ like 18 like 30 and F_2_ I don't know 60 plus. And then some number here. And what happens is that turns out the first letter before the underscore is like the gender, the second letter is some treatment variable, and the third letter is the third set of strings is like the age range. And in order to tidy this data, we would use something like spread and unite. But we don't have to worry about that for now. The data sets that we're going to be using are pretty tidy. So the first thing we're going to talk about is transforming the data to answer questions that we might have. So the thing we're going to use to do this is something called Ggplot. It's backed in C, so it's very, very fast. And basically the majority of this tutorial is based on this site here. So once we publish the notebook, you guys can take a look at the original. So Ggplot is really useful because it produces a grammar. And it produces a grammar by introducing verbs. And the usefulness of having something like a grammar rather than something like pandas where everything is a method is that once you learn the grammar, you can kind of figure out what you need to do to get the result that you want. Versus in pandas, it's explicitly a single variable, sort of a single method name that you can just look up or memorize. So in Ggplot, we have a couple of really basic and really sort of core transformations. We have filter, which we have select that selects columns, filter, which selects rows, arrange that sorts, mutates that changes and creates new columns, summarize, which summarizes values, and group by, which allows us to split the data and then apply these same transformations on top of the splits. Are there any questions so far? Cool. What's up?
Is the Markdown file going to be available on the Facebook group?
Yeah. So it'll be on GitHub. So here what we're going to do is we're going to call head on the MPG dataset, which is basically miles per gallon. And what heads does is it just lets us see the top few rows of the data. The first thing we want to do is we want to select. And so we can do that by calling the select function, having the first argument as the data frame, and then passing in the various columns that you want to pick. So once we do car models is equal to manufacturer model year, we can select it. Very simple stuff. We can also do things like select everything except for certain columns. And by doing that, we can just pass in a minus sign. We can also do things like select ranges of columns, which is really simple, by adding a colon between the column names. The same kind of stuff happens with filter. Instead, we pass in the data frame, and then pass in just a bunch of conditions that we want on our data. There's no need of passing in strings as the column names, because these kind of functions are aware of the data that's sitting underneath. And so here I can just say that the year variable is this, and the manufacturing variable is the Audi. I do also want to mention one thing that makes writing code much easier, and it's called the pipe operator. And it's pronounced then. And the reason it's pronounced then will be very clear once we describe what it does. So once we have very complex transformations of the data, we might want to do something like take the data, filter by these variables, and then select that column, and then take me the head, take me the first three columns. And this is a little confusing the more complicated it gets, because we kind of have to read inside out. The pipe operator lets us inject arguments into the beginning of the function. So I kind of give like just a written example to make it more clear. You can think of something like this. Right? Say we have a function that takes an A and B. It is equivalent to a pipe f of B. It's kind of weird, but what this lets us do is the following. Every time we do something with the dplyr verbs, it gets us a new table. And every function we need to do using dplyr takes the first argument as a table. And so by doing this, we're able to sort of build a chain of different commands and a chain of different transformations to produce basically more readable code. So this block right here and this block do the same thing. So by reading the second block, it's much more clear what we're doing. We're filtering by some conditions, taking the model column and showing the first three rows. And really, the pipe operator is here to make code more readable, because a lot of the stuff that we'll be doing isn't necessarily production code. And it's going to be our attempts to translate and communicate analyses and our understanding of the data. Right. So here we have a range, which basically sorts the data frame on the column that we pass in. If you want to decrease it, we can do this. So these are some pretty simple stuff. Here we're just sorting by the first column, and then sorting by the year column. Once we can do that, once we have ways of picking what data we want to see, we can then filter the data once we can filter the data and select the columns that we want to have, we can then mutate. And mutate basically allows us to add new columns into the data. So here we have the miles per gallon data set, and I want to have the average miles per gallon, the city miles per gallon plus the highway miles per gallon divided by 2. And we'll and as you can see, we have this new column here that is the transformation that we want. The last two things that we want to do once we get the data that we want in the right shape, and we transform the columns that we want to be the right data type, we can then summarize. And all summarize does is it takes in an aggregate on the column name. So here we have the CTY variable and the highway variable, and we want the mean. And then we just name our new columns the same way we name our new columns in mutate, which is just saying that, like, you know, some new column equals some transformation of old columns. And then here's just a short list of some of the transformations we have. Right? we have standard deviation, min, max, median. We can use n to count the number of entries, and distinct to count the unique entries, and first and last, which basically just takes the first and last value in a certain column. Once we do that, we have everything we need to do something called a group by. And the group by just selects the data matched on a certain column and splits them into multiple tables. Once we have them split into multiple tables, we can do things like aggregate that aggregate specifically on those different splits. So for example, let's first take a look at the original data set, MPG. The MPG variable has this manufacturing variable that is, there's different different car manufacturers. There's Audi, we have Chevrolet, Dodge, and etc. And our question is, what's the average miles per gallon conditioned on the manufacturer? Here we can do that by using the group by. We just say miles per gallon, group by the manufacturer, and then compute all these averages. And so now we should see as many rows as there are manufacturers in our data set. The next thing what's up?
What happens if you try and group by a continuous variable, for example, so an integer, whatever, a temperature range? Will it convert all of those into factors and then try and group by them?
If it's an integer, it might try to do it using factors. But if it's a float, there's to be thrown an error. There's a function called cut, which basically takes in a column that's continuous, gives it a bound, and then we'll split it into those bounds. So you can say, group by every range 5, and I think you can sort of easily do that. Once we're able to transform data in a really effective way, we can actually try to visualize it. And the library we're going to be using is called Ggplot 2, which is part of Tidyverse. In the same way that Ggplot tries to create this grammar of data transformations, Ggplot 2 tries to produce a grammar of data visualizations by using things like geometries, aesthetics, facets, and scales. And basically, once you know what all these 4 things mean, you can, relatively speaking, produce any visualization that you want. So again, we're going to have the same data set. And we're going to look at these 2 columns, display and highway. So what we can say is we want to call Ggplot on the data, which gives us a graphic that has the data as the underlying structure. And then we say, I want to add points to it by just doing a plus sign with geom point. And we say that the mapping is such that the x variable is the display variable and the y variable is the highway variable. In the future, we don't have to actually include this. We can just do it this way, but let's do it this way. And really quickly, we have a data visualization of the display variable in relation to the highway variable, and we can see this negative correlation. What we can do is, if we know that we always want to map the x and y variables to these 2 variables, we can actually put them into the Ggplot object rather than putting it into the point object. By doing so, we can set the mapping here, add new variables like color, and then rerun the code. So now it'll easily give you a legend split by these different variables and then colored based on the class of the car. Okay. And what you can do is, if you just look at all the different mappings that are available, we can effectively know how to map different variables to different things. So we can have variables for color, the transparency, the shape, the thickness, a whole bunch of things. Here we're using shape. And there's a whole theory of sort of understanding how we can encode different variables into different visualizations. For example, the most important variable should always be position, for example, because even if something's 2 or 10 or 12 pixels off, you can tell that they're not aligned. Same with color if you're using categorical variables, right? Things get trickier when we use something like a pie chart, which is actually the worst visualization you can make. And that's primarily because you can't tell the difference between something that is 10 degrees and 15 degrees. Whereas if something was 50% different on a line, you can always tell if the value difference, right? And so when we're thinking about how to make our data visualizations, we should be thinking about them in terms of how important is this variable, and how easily can we distinguish between differences in the values. Another one that's really interesting, for example, is area. If we want to use area to encode a variable, something that is twice as big has to be 2.5 times bigger for our brains to actually think is twice as big. And so by doing stuff like this, it allows us to communicate our points better. Right? Like if something's twice as big doesn't feel twice as big, maybe the person we're presenting to might think it's less important. Another small thing we can do is using something called a facet, which allows us to split our plots into as many as we need to split by the class. So here what we did was we made the color different for every set of data points. Instead, we can use facet, specify the number of rows. Whoops. And we can really easily create all the plots based on different classes. So this might be really useful when we think that the data is sort of strange things are happening to certain classes or certain different categorical variables. Using facets is a really easy way of sort of splitting everything out, and then using color and shape to help us see the differences. And the general idea here is that with facets and geometries alone, so this geom underscore, we pretty much have everything we need, right? All that's left to do is to understand and learn what other kinds of geometries there are. So here we have points. If we don't want to have points and we want to have sort of a point of best fit, we can replace points with smooth. And this produces this locally weighted least squares solution to our problem. If we want both, we just add both, right? Here we say that the data is such that the x is the display variable and y is the highway variable, and we both want the points and the smooth. If you want to see the points and the smooth, but also split by every manufacturer, we just do plus facet manufacturer. And now you can sort of see how, using these really simple methods, we're able to make very complex visualizations that help us understand the data without having to do all this data transformation. So here we're doing things using group bys and summarize. And so what we're doing is we're grouping by the class, we're finding the mean highway variable, and then creating something called a column plot. Pretty simple stuff. So at the bottom of this notebook, I gave some examples of some really, really cool data visualizations, and I wanted to sort of show you some of these. So this is basically the base list of data visualizations that I reference when I'm trying to communicate something. I think these will give you guys some good ideas of what's possible. Okay. So I think, let me try to zoom in. So we can do things like encircling, which is really cool. Just by having this one line here, we're able to automatically draw circles in our data to sort of draw our eye to something. Here we're using a smooth, estimating the density, the population density using the size, and then changing the color based on the state. It ends up being like 5 out of code. Right? Same thing here. We see some more cooler examples when we go down, where we can look at the marginal densities of this data. Right? We can also make bar charts. We can build visualizations to look at correlation matrices. This is often used to look at, for example, your machine learning outputs, seeing which features positively influence your prediction versus which features negatively influence your prediction. We have lollipop charts. And generally just a bunch of different interesting visualizations that we can use to sort of try to communicate our points. This one's like a one that I really like, which allows us to see very big differences in change in these variables. This. And again, most of the code is very simple, right? Here, all we're saying is we're adding a bar chart. We want this certain theme, and we want the labels to look like this. And if you try to make this up in Python, it's actually really, really hard. It ends up being like 70 to 100 lines of code every time I want to make data visualization. What's up?
Is this package only available in RStudio, or is it also available for other things?
So Ggplot is a library made for R. RStudio is just sort of like a way of like programming there. In terms of Python, there are things that are trying to be like Ggplot. So we have something like Seaborn, which doesn't really do the same thing because there we're still saying that like every single data underlies a different kind of plot, and so overlaying multiple plots become very unintuitive, right? Most of the plotting packages that have been invented prior to Ggplot mostly look like MATLAB, and MATLAB is very much like I want to implement like an axis object, and then I want to select the axis, and I want to put a line there, and then I want to put another line. Right? If I want to have circles, then I have to like figure out the x, y coordinates of these circles, and then tell me how wide the circle is, right? And so it's very like to the meta. If you care about like specific like pixel alignments and how long the ticks are, and how the characters look, you move into MATLAB. But then you have like 800 lines of code to try to make a plot, right? Whereas here, like all we can do is say like the x variable is this, the y variable is that. I want this to be colored, like, give me a plot. The beauty really comes in using things like facets. Like every other library, you have to write it in a for loop. So you have to like initialize, you have to know in advance like how many variables you have, initialize like the right size of grid, then you like do a for loop and you select the object, you put the lines in, you put the circles in. And that just becomes like really, really like boilerplate code that nobody wants to write. And so really, R is for that like first like 50% of your data analysis when you're trying to just figure out what's going on. I still recommend using something like Python to do stuff like building models and moving things into production. But just like the efficiency of writing R code to produce these visualizations is just like very much worth learning. And really it takes like an hour. So let's see if there's any more interesting visualization. Yeah, so this is like a bar plot, but we also draw the data points on top of the box plot in order to see if there's any sort of weird distribution. This stuff is really cool. This is something called the tree map plot, and it basically like splits up a rectangle based on the scale of the categorical variables. And I think that's it. Let's see some time sweet stuff. Like stuff like this would, like if you want to do this in Python, you have to like draw out rectangles and like start from that, and so stuff like this makes it really, really easy. And something like this only takes about like 20 lines of code. But that's basically it. Like all we wanted to do today was introduce you guys to like the Tidyverse. We're hosting something. We're trying to host the Kaggle initiative this term, where we let people compete on Kaggle. And one of our goals is to basically pay you guys to write these things, and like pay you guys to produce like quality analyses for your own portfolio. So, if anyone's familiar with Kaggle, basically Kaggle is a online like sort of leaderboard, an online platform to find data sets and write analyses, and in particular compete as well. Competing isn't as I don't think competing is as relevant, but one of the things we would love to see from you guys is to write kernels. And so here we used RStudio to write these kernels on our own computers. What actually happens on Kaggle is that you're allowed to, you're allowed to host these notebooks on Kaggle and then sort of get upvotes and get feedback from the community. So this is an analysis that somebody did using the flight delays and cancellations data set. So basically, this is kind of one of the really like fundamental analysis on like these flight delays. So we really welcome you guys to sort of find data sets that you're interested in, use something like Tidyverse or use something like Python to do analysis and publish these. And our goal is to sort of reward you guys financially. we're thinking of sort of giving away prizes based on like how well you guys rank on these. And so if you guys get something like a silver or a gold, we might be able to like give you a gift card or sort of work with our sponsors to think of some fun prizes for you guys. What's up?
I just had a question about Ggplot and like all the stuff that does it communicate with other packages like if you wanted to make like an interactive plot like with Shiny, could you use like Ggplot?
Absolutely, yeah. So there's actually has anyone heard of something called Plotly? Alright, so Plotly is like a way of making plots in JavaScript to make things interactive. There's a thing called Ggplotly. So once you make your Ggplot object, it's basically a picture. And if you call the Ggplotly object on the Ggplot object, it automatically becomes a JavaScript object with interactive components. And so that's like 8 characters to turn your thing into a website. Yeah, everything like this ecosystem of like the Tidyverse is very, very powerful, and even cross to other languages like Python. There's a bunch of different encodings and formats that makes that really easy for everyone to use. Are there any other questions?
It seems like a lot of syntax, but really like you could just find it all in one website, and it all follows the same order. And like, don't worry if you didn't really get any of this. Like, no, I know like there's.
I hope you got some of it.
Yeah, like hopefully you got something out of this. If not, like Robert and I will like be mentoring people while like we do hands-on Kaggle competitions, or like the kernels. And we also have office hours like beside the CS Club. We'll get those hours out soon. But yeah, if you guys, should we try to form teams now, or?
I would probably say it another time. It's pretty hot in this room.
Yeah. If you guys have like any remaining questions, like just feel free to come up and ask. Because I know like a lot of people are shy and don't actually ask questions until after we're done.
If anyone was like trying to set up our studio and got really frustrated and quit, we can help you with that now as well.
Oh, and also the doc is online as well.
So you go on GitHub. So this is like a very quick overview of the stuff that Tidyverse has to offer. If you guys are interested in doing a longer tutorial, like the guy who invented the whole damn thing wrote a book called R for Data Science, and it basically covers what we covered and also the modeling aspects, and being able to use something like Modeler and Broom to make data transformation easier. They're very similar, very similar code. You are really yeah, so that's it from us. You guys are all welcome to sort of hang out afterwards. We'll sort of chat about stuff. Otherwise,
We also have Python notebooks for getting started with pandas. If you want to get ahead a bit, those are public. Yeah, so we have a guide.
yeah, we also have similar guides to do data analysis in Python.